Let's now study the formulae regarding circular motion. Before that, let's take a look at some definition. The first definition we're looking at is angular displacement. Angular displacement is the angle theta an object moves through with respect to the center of rotation. In this diagram here, we have actually shown a small, in this diagram here, we have actually shown an object in circular motion that moves through a small angle, delta t. The unit for angular displacement is radian, and it is dimensionless. And its co-relationship to displacement, in this case, this will be the displacement of the circular motion, all right? This will be the displacement of the circular motion, which is along the circular arc. And the formula will be r theta is equal to s, and s is the displacement. So r theta will be equal to s. And note that the theta is radian, and theta has a unit of radian and not degrees. And 1 radian is defined as the angular displacement of an object in circular motion where the ratio of the arc length s and the radius r is both equal to 1. Meaning to say, if you have 1 radian, then your displacement is 1 meter and the radius of the circular motion is 1 meter. Okay, now let's take a look at angular velocity. Angular velocity is defined as the rate of change of angular displacement, as indicated in the formula here. You could also calculate that by the number of revolutions per second multiplied by 2 pi. Or you can calculate the angular velocity by taking 2 pi divided by t, where t is the period or the time taken for a complete revolution. Finally, let's take a look at the average speed. For the average speed, let's refer back to this diagram. In time delta t, the object in circular motion would have moved delta s. Average speed will therefore be the distance traveled along the circular arc divided by the time it takes. So change in s, delta s in this case will be using this formula will be r delta theta. From this expression, we can see that the delta theta delta t is in fact the angular velocity. Hence, the formula v equal to r omega. Let's take a look at the acceleration for the circular motion. To do that, we need to draw a vector diagram to determine the change in v. As we know, acceleration is rate of change of velocity. So in this case, from the circular motion, we can now draw this vector diagram. And the angle that's subtended between the change in v and your u or v is in fact approximately 90 because the angle delta theta is really small. And also note that in this calculation, the speed of the object in circular motion does not change, and we denote that by v. Assuming this to be close to 90, change in v now is equal to v tangent delta theta. And tangent of any very small angle can be approximated to the angle. So in this case, change in v is v delta theta. So we can now plug this inside the definitions of acceleration, where acceleration is the rate of change of velocity. And from here, we can derive that acceleration is equal to v omega. And using v equal to r omega, we can then have the expression r omega squared or v squared over r. Finally, it's important to take note that the direction of acceleration is perpendicular to the direction of the velocity, which means if it's perpendicular to the direction of the velocity, the acceleration is always directed towards the center of the circular motion.